Ever wonder what holds, like, literally everything together?
Mm.
We're going to take a deep dive today
Okay.
into the strong force.
All right.
So, it's this crazy powerful force that binds, like, the universe at its tiniest level.
Right.
We've got your notes, pasted text, and we're going to use them to, figure out all the newest discoveries about this force.
Yeah, it's amazing. Like, it's actually responsible for matter existing.
Yeah.
As we know it. I mean, without it, atoms would just poof.
Really?
Gone.
Huh. So it's kind of like the, the super glue of the universe.
Yeah, exactly.
So we know atoms are made of these teeny particles called quarks.
Mm-hmm.
Can you, break down how this force acts on them?
Okay, so imagine quarks, right? Like super tiny Lego bricks, but they're always, vibrating.
Okay.
And these quarks, they have this special thing we call it color charge.
Color charge.
Yeah, and the strong force is imagine the strongest magnet ever. It pulls quarks together if they have different color charges, and that's how they get stuck in the atom's nucleus.
So like a color coding system.
Kind of, yeah.
But not real colors.
Exactly, it's this color charge thing.
Okay. But how do they, actually exchange this force?
All right, so that's where gluons come in.
Gluons.
Yeah, think of them like tiny messengers. They're zipping between the quarks constantly.
Okay.
They're exchanging this strong force, keeping the quarks all bound together, like a subatomic game of catch.
Whoa. With really, really high stakes.
For sure.
So I'm trying to wrap my head around this color charge and the gluons and how it all works.
Yeah.
Can you explain a bit more?
Okay, it's a tricky concept. So let's simplify. Imagine each quark can be one of three colors.
Yeah.
Red, green, or blue.
Like a traffic light.
Yeah, kind of.
Okay.
Now, inside an atom's nucleus, there's always a balance of these colors. Yeah, so the total color charge is neutral. And the gluons, they're like color-swapping ninjas.
Ninjas?
Yeah, ninjas.
Okay.
They're constantly changing the color charges of the quarks to keep everything balanced. So a red quark could shoot out a gluon and bam, it becomes blue.
Wow.
Then a nearby blue quark grabs that gluon and it turns red. It's this constant back and forth, exchanging gluons, shifting colors.
Wow.
That's what creates the strong force.
That is wild.
Yeah.
So this thing we can't even see
Right.
is holding our world together.
Literally.
But there's got to be some kind of theory, some rules
Yeah.
that govern all this quark and gluon action.
Absolutely. And that's where Quantum Chromodynamics comes in, or QCD for short.
QCD?
Yeah, it's like the rule book for quarks and gluons.
Okay.
Explains how they behave, how they interact through the strong force.
I was reading in pasted text that gluons don't just interact with quarks, they also interact with each other.
Yeah.
How does that affect things?
So that's one of the really crazy things about QCD. Unlike other force carriers, gluons, they can actually interact with each other. It's like they create this web of interactions inside the nucleus.
Okay.
And that makes the strong force super strong, but only at really, really tiny distances. Like way stronger than the electromagnetic force, which is what makes electrons and protons do their thing.
So the strong force, it's not always the same strength.
Nope, not at all. In fact, one of the most mind-blowing things about it is this thing called asymptotic freedom.
Asymptotic freedom?
Yeah, basically, as quarks get closer, the strong force actually gets weaker.
Wait, really?
Yeah, it seems counterintuitive, but it's been proven, and it's super important for understanding quarks.
Wow, that changes, everything I thought I knew.
Yeah.
Okay, so we've been talking about the really small stuff, but pasted text also mentioned the strong force in nuclear fusion.
Yes.
So how does this force play a role in something as gigantic as a star?
Well, the strong force is absolutely crucial for nuclear fusion. It's what powers the sun and all the other stars. So in a star's core, where it's crazy hot and the pressure is unimaginable,
Yeah.
protons, which have the same positive charge, they're forced super close together.
So the sun's like a giant nuclear fusion reactor.
Exactly.
Wow.
And normally these protons would push each other away because they have the same charge.
Right.
But in the core, it's so intense that the strong force can overcome that repulsion.
Right.
And once the protons are close enough, bam, the strong force kicks in. It binds them together to form heavier elements like helium. And when that happens, massive amounts of energy are released.
So that's where the sun's energy comes from.
Exactly. It's this amazing balance of forces that lets stars shine for billions of years.
It's incredible to think this force is behind everything we see, from tiny atoms to the sun's light and heat.
I know, right?
So how does all this fit into the larger world of particle physics?
Well, the strong force, along with gravity, the weak force, and electromagnetism, they're all part of the standard model of particle
The
physics.
standard.
Yeah, it's this awesome model that explains how particles and forces work at the subatomic level.
Okay.
And it's been incredibly successful at explaining things.
So the strong force, with all its quirks, it's just one part of this grand model of the universe.
Exactly.
That is so cool.
But, as great as the standard model is, it's not the whole picture. There's still a lot we don't know about the universe.
Like what?
Like dark matter and dark energy, for example. The standard model doesn't quite explain those.
Right.
So understanding the strong force even better, that could be the key to unlocking some of these mysteries.
Wow. So much to learn.
I know, it's exciting.
Well, this has been an awesome deep dive. I have a whole new appreciation for the strong force now.
It's a pretty amazing force.
It really is.
It's holding us together, powering the stars, and we're still figuring it all out.
It makes you realize how much wonder and mystery there is in the universe. So to our listeners, think about this. Everything around you, your body, the chair you're sitting on, even the air you breathe, it's all held together by this incredible force.
It's pretty mind-blowing.
It is. Let it spark your curiosity, maybe inspire you to explore the universe a bit more. Keep asking questions. Keep that curiosity burning.
Yeah, that's what it's all about.
Until next time.
See ya.